Welcome back to our lesson on multiplying in algebra with percents. We are just going to review a little bit where we left off. I know I had to rush a little bit at the end of the last video, so I want to make sure that we understand this concept. The question again was a wool sweater that usually costs $58 is on sale for 15% off. How much money can be saved by buying the sweater when it is on sale? Now, I would typically immediately leap to doing it the way on the left and think, okay, what is 15% of $58? Because that's the amount that I'm going to save. And I would think, okay, I can either set this as an equation saying something like x equals 1500ths times 58, or I could use my is of percent triangle and I would know that I want to multiply 15% and 58, or multiply 15 hundredths and 58. So 15% of 58 is 8 and 7 tenths, telling me that you can save $8.70 when buying the sweater on sale. Now, just because this is the way that I do it doesn't mean that this other way is wrong. It does take a little longer, but I know that some of you were automatically doing it this way, and I'm not sure if that's because this is how you were thinking about it, or possibly you didn't read the question carefully first and were first trying to find out how much the sweater cost. But that's fine if we want to do it this way, and also it brings up a great point, which is that the equation you make for the first way and the equation you make for the second way actually can be simplified to equal the same thing. So some of you knew that 85% was the difference between 100%, how much the sweater originally cost, and 15% the amount that you were going to save. And you knew that you would buy the sweater for 85% of 58, and then turning this into a fraction or a decimal, 85 hundredths times 58 equals 49 and 3 tenths. So you knew that if $58 was the original price and you were going to pay $49.30, then the difference is how much you save. So you would have subtracted this 49 and 3 tenths from $58 to get $8.70. And this here is the equation for that. The 1 or 100% of $58 minus 85% of $58. And if you notice, this problem here and this problem here relate to each other because of the distributive property. If you had factored out, that's what we call it when we take out a common factor, this 58, and kind of put it over here, and then we would have had the 1 minus 85 hundredths. Now remember, if I wanted to go backwards and distribute, I could do 58 times the 85 hundredths, that's this here, and 58 times the 1, that's this here, and find the difference then. However, I could also do it this way where I solve what's inside the parentheses first, and 1 minus 85 hundredths brings us this over here, which is 15 hundredths times 58 equals x. So take the time to look over that. If you make sure you write it down, and if you have any questions, try to be very specific about what it is that's confusing you, which means you take the time to look over it, you try to solve it out. And if there's something that's stopping you or catching you up, identify that area and then I'll be able to better help you. But if you come in and you say, oh, just the whole thing confused me, then since there's so many steps, it's hard to figure out exactly what to clarify for you, especially because I have a feeling the whole thing didn't confuse you. It just takes a little effort to figure out exactly what part does confuse you. All right, so the next question, this one directly relates to what the project is about. So the Paxton Emporium buys graphing calculators wholesale. That means they buy them in bulk. So for $100 each, and then resells them each for 10% more. Now, the question, I phrased it terribly, but write an equation for and determine how much Paxton Emporium sells graphing calculators for. Okay, so essentially I want you to write an equation to match this information and to help us figure out the unknown quantity, and then I want you to actually figure that unknown quantity out. So we want to start off with the idea that Paxton Emporium buys graphing calculators for $100 each and then resells them for 10% more. So they're not reselling them for 10% of the price, but for 10% more, which means 100% of the price and 10% more. So when we multiply this to get a size change amount, we're going to multiply it by 1, which is the 100%, and remember that's what that decimal is, 10% more. So 100 times 110. But remember, I don't actually need that 0 there because it's at the end after a decimal, so I can just write it 1 and 1/10. And then if I actually want to write it out as I'm saying it, I would say 110%, or 1 and 1/10 of 100 is what? So remember that what is that unknown variable. So if you can't do it in your head, it is definitely okay to write it out and go ahead and solve it. So I would like us to practice doing the traditional way, but if you're more comfortable doing another way at the moment, that's fine, because I really want you to get the concept of the percents, but it's definitely good to practice the multiplication. So remember, we do 1 times 0 is 0. I know that's messy because I'm trying to write it with my mouse. And 1 times this 0 is 0. And 1 times 1 is 1. Could have also just done 1 times 100. Now on the second row, remember, since this is second place over, I need a placeholder to hold the place for that number there. And again, 1 times 0, 1 times 0, 1 times 1, or 1 times 100. And so that gives me 0, 0, and 1. And then remember, what I'm going to do is I'm going to add those up. And I'm actually going to type that out because I think that'll be a little neater. There I go. 0 and 0 make 0, 0 and 0 make 0, 1 and 0 make 1, and this one here makes this one here. But I need my decimal placement. I've only got one digit to the right of a decimal, so I'm going to put my decimal right here, which, since it's followed by a 0, I can actually just get rid of all of that, and 1 and 1/10 times 100 is 110. So X is 110. Paxton Emporium is selling their graphing calculators for $110. So the next part of the question is, on April 1st, Paxton Emporium will have a 10% off sale on their graphing calculators. Write an equation for and determine how much they will sell for. So I'm going to write my equation first. I've got my $110. That's my the amount that Paxton Emporium is selling them for, not the amount they're buying them for, but how much they're selling them for, what we determined in this first part. And they're going to have a 10% sale. Now that means it's going to be 10% off. So they asked us how much do they sell for, not how much are the people going to save. So how much they sell for is going to be the difference. So that is not going to be 10%, that is going to be 90%, which I am actually going to write as 9/10. Now we can do what we did in the first problem, is write it out as we say it. So 90% of $110, or 9/10 times 110 equals what? X, my unknown amount. Okay, so I set that problem up over here, this 9/10 times 110, and I think most of us can do this mentally, but just in case, 9 times 0 is 0. So 9 times 1 is 9, and 9 times 1 is 9. I need my decimal placement, which there's only one digit to the right of a decimal, which means my decimal is going to go right there. So the graphing calculators are selling for $99. Now I'm going to guess that's not what you were expecting. I'm going to guess you were expecting that if there was an increase of 10% and then a decrease of 10%, you probably thought it would be back at the starting amount of $100. But that was not the case. We're actually losing money instead of making a profit because we're selling them for $99, we being Paxton Emporium, when they were bought for $100. All right, so we are going to look at an example from your book. It's actually on page 515 from chapter 8, section 5. All right, so in this example, it says, suppose the membership of a club increases by 10% and then decreases by 10%. Is the membership back where it started? So let's take a moment. If the membership was originally M, so we have an unknown amount, doesn't matter what it started out with. Then after a 10% increase, it is what percent? And we talked about this a little bit already. We said that it's going to be the 100%, the original 100% amount, and the 10%, which is 110%. There we go. Just about got that in there. Now, the 10% decrease means that it's 90% of what it was after the increase, because 10% is the amount it's decreasing, so 90% is what is left. So the final membership, let's see if I can type it if it'll come out a little easier, is 90% of the 110% increase of M. So do you kind of see how that multiplication there, that stands for the of? Let's look at that. It's 90% of the 110% of the original amount. And then whenever we do a problem like this, we like to write it as a decimal. So 90% is the same as 90 hundredths or 9 tenths times 1 and 10 hundredths or 1 and 1/10. So what we want to do now is we want to do the arithmetic. So we would do 9 tenths times 1 and 1/10, and take a moment to try to solve that. And it will actually equal 99 hundredths times M. So remember, 99 hundredths means 99% of M. So it is 1% less than it was to begin with, because instead of being 100% M, the whole amount, it's only 99% of M. So the membership is not back where it started. So this is going to directly relate to what your project is. So we're going to take a moment though to use this example, and I'm going to help you kind of figure out some ways to solve your project. And I'm going to help you figure out how we might figure out how to get back to where we started. Because if the original amount increased by 10% or decreased by 10%, how could we get back to the original amount? So if it increased by 10%, how could we figure out how much the new amount would need to decrease to get back to the original amount? And it always helps to have an equation. So here I said the unknown amount, we're trying to figure out how much it would need to decrease by, times the new amount, which is 110% of M, this being the original amount, equals 100% of M. I use this question mark because I think that this right here is a little confusing, but essentially what we're trying to figure out is what we could multiply the new amount by, the 110% because of that 10% increase, to get it back to just being 100% M or just M. So whenever we want to have it set up like this would be our A times X equals B. So this is our unknown that we're trying to find. Remember that we can go ahead and actually divide by this amount here, this 1 1/10, to get this by itself. And it looks like I forgot to put my fraction bar in, so let me go ahead and write that in there. All right, now on this side, I didn't write it in, but when we divided this by 1 1/10, it canceled out, leaving us with just this unknown here. On the other side, though, we still have to solve it. 1 divided by 1 1/10. Now, if this is still confusing you, the figuring out what you divide both sides by, you can also use your fact family information. So remember, if you were to have a fact triangle like this, and you were to put, let's see, your unknown amount here and your 1.1, because the unknown amount times 1.1 equals 1. And you could figure out, okay, this 1 divided by 1 1/10 equals this unknown amount. All right, so 1 divided by 1 1/10 actually gives us a repeating decimal answer. It's 0.909090 repeating, or repeaten, which I can write like this, but I do need my little bar over the top to indicate that this part here will be repeating forever. I could also round it if I wanted to. That's what these, when they're curved like this, they mean about. So I could round it to 91/100ths, which makes it a little easier to say, because 91/100ths we would say is 91%. So if the original amount was increased by 10%, giving us 110%, I would need to multiply that by 91% to get back to my original amount. So, and if 91% of 110% of M gets us back to where we started, then that's a 9% decrease. Because this 91% here, I would take it away from 100%, that difference being 9%. So if I increase by 10%, I need to decrease by about 9% to get back to where I started. Now take some time to really look at this, really try to work it out on your own. And this is why I advise you trying to watch this before Monday, because then if you have questions, you can ask them, you can clarify, get clarification rather, so that you are able to actually solve the project problems, which I'm going to briefly go over now. So in section 8.5, it will give you a lot of resources to use to help with this if you need some additional support. But what we talked about just a few moments ago, was that a 10% increase followed by a 10% decrease does not get a quantity back to where it started. Now your job for this project, aside from having watched these videos and taken the notes on the packet, is to answer these 3 questions. The first, A, suppose an original price is reduced by 20% for a sale, so it decreases by 20%. what percent must the sale price increase in order to get back to the original price? So you would probably want to use the information we did on the last slide to help you try to figure that out. Make sure you show your work because that's what I'm going to be grading on a lot of. Even if you don't get it exactly right, you can't find out what the exact answer should be. If I can see you really putting that effort in, really using the information that we've learned to try to solve it, that's where you get a lot of your points. Again, I want you to persevere and explore these different ways to solve these problems. All right, B is many people would answer 20% to the question of part A. But we already talked about how if you decrease by a certain amount, increasing by that same amount won't get you back to where you started. And I need you to write a short explanation of why. So if you reduce the price of something by 20%, why can't you just increase the new price by 20% to get back to where you started? And you can put that on your own piece of paper, your own lined piece of paper if you want. I provided an answer sheet with some lines to answer A and B. Again, for A, show your work. For B, make sure we have complete sentences. But if you need more room, feel free to add on that extra paper. Just make sure you staple it on, make sure it has your name on it. Don't want to risk losing anything. All right, now C is probably the most in-depth part of this because you're going to create a table that indicates the percent you need to get back to the original price after a decrease, and you're going to do decrease of 10%. Hey, we might already have the amount you need to get back to your original price. Of 20%, which you should have figured out in A, of 30%, of 40%, 50, 60, 70, 80, and 90%. And what I want you to do is really think about it and try to explain in general how to calculate the percent to get back to the original price of an item. If you can, see if you can figure out what to do if they haven't given you a percent, if there's a pattern, what to do if we have an X percent. That means just a sort of general rule. Could you come up with a formula or a pattern where I could put any number in that we're going to decrease something by and then figure out how to get back to the original price? So does that same getting back rule work if the price is increased by just X percent, just any number percent? All right, so at this point, ideally you have watched the video, you've taken notes, you've paused and rewound, you've gone back over, you've really tried your best to understand what we're doing. You've incorporated other information that we've learned so far, and you've written down any questions that you have, and you'll be ready to ask them of me on Monday. Because remember, this is due Friday. I know it seems like a lot, but aside from your test this week, we don't, and making sure you have all your materials ready, your notebooks due Friday, making sure that you did your pre-test, the practice test online, which counts as a homework grade. You don't have any other homework until Thursday. So you should have plenty of time to get this done. This is worth 30 points. It's a big chunk of your grade. If a lot of you are saying it's taking a lot of time and effort, I may even consider increasing the amount of points, because if you are putting in this time and this effort and I'm really seeing you work on this, I want to make sure it counts for you, that it's worth this real effort, this perseverance. It's what we're working on. And again, if you have any questions, in the comments, email, classcraft, or in class. And I will see you guys Monday. All right. Be mathematicians, get your work done, but also enjoy your weekend. See you guys.